So my name is Sushant. I'm a software engineer at Google. I have completed a master degree in computer science from IIT Bombay, and I have around 7 years of experience, both in software engineering and machine learning. So, interviewer will usually ask you once you write a problem, what's the time complexity and what's the space complexity. Space complexity, not much. Many interviewer ask what's the space complexity of your problem, but it's good to know how to calculate space and time complexity. We use BIGO notation for time complexities. BIGO notation is nothing but what's the worst. How worse your program can get. So it's a worst time complexity. So I'll just let you know that what different BIGO notations are called. So if your complexity is O of 1, it's called a constant time complexity. Usually when you write a program, if it happens to be a dynamic programming, it usually comes under quadratic time or cubic time, or it may come under n log n if you are using some advanced data structure like segment tree or Penwick tree. You will hardly get any logarithmic time complexity problems because these are just searching problems like binary search. And factorial time or exponential time, these problems usually belongs to NP hard class of NP complete problems. You may get a problem like a traveling salesman problem. The complexity of that problem is actually a factorial time, but using some dynamic programming tricks, you can reduce it to exponential time. So I'll just wanted to clear out some doubts. Many people have this doubt, like when you see a loop in the program, the complexity usually goes to linear, but that's not true. As you can see in this case, on the left hand side, you can just see just three instruction. So you will say that the complexity is constant time. Yes, it is constant time. But on the right hand side, you will see a loop, that while loop is there. So we'll say the complexity is a linear time, but it's not, because the limit of that loop is a constant. You are not getting this variable from some input. So this is a constant time. So your complexity depends on what input you are getting. If your program is directly proportional to the length of the input, then you can say that it's linear time or log n time, whatever the operation you are using inside the program. For this program, the complexity is linear time because there is a n which you will get from input or some other variable. We don't know the value of n. That's why we say it's a linear time, because you are using n because it is an input. You don't know the value of n. But if you know the value of n, if you put some constant here, it will become constant. Same here, you say that it will go only n by 3 times. The complexity will be O of n because the contributing factor here is the n. The complexity of your program will be directly proportional to n. That's why the big O of n we are using as a complexity. So these are just example of quadratic complexity. When you see a nested loop inside a loop, that will going to increase your complexity. The more nesting is there, the more complexity will be there. One nested loop inside another loop, and both are running till n. So your complexity will be n into n square. Both the loop are running from 0 till n. So we are saying that the complexity is n square. But even if you replace 0 with upper induction variable, the complexity will still be n square, because you can calculate that how much time will be required for each loop to run. So it will require n, then n minus 1 till 1. But once you sum these up, you will get this formula, n into n plus 1 by 2, and you will get a n square term. So that is the significant term in that equation. So n square term is the significant term, and your complexity will come to n square. Now, this is just an example of binary search. What it does, like it divides the array every time in half. So if you solve their reconciliation, you will get that the complexity is log n. There are some other problems which comes under NP complete class. They usually don't have linear time solutions. You will have to provide a exponential solution or maybe a factorial time solution. But interviewers are good with that. They know that giving you an NP complete problem. They just want to see that whether you, misclassify it with the dynamic programming and try to solve it in linear time.